All right, let's dive right into this explainer. Today we're taking a really close look at how Slack's engineering team tackled some pretty complex mobile accessibility challenges on Android. It's honestly a fascinating look at the exact point where raw code meets human empathy.
Think about it for a second. How exactly do you navigate a massively complex app if you literally can't see the screen? It's a fundamental question of inclusive design, and today we're going to explore exactly how Slack answered it by analyzing their recent accessibility audit. They faced some totally unexpected hurdles, and their solutions are absolute masterclasses in engineering.
To figure that out, we've got a great roadmap for this explainer. We're going to start with Slack's accessibility catalyst, then look at fixing the screen reader, move into visuals, gestures, and navigation, and finally wrap up with some crucial lessons in inclusive design.
Starting off with Section 1, Slack's accessibility catalyst, specifically looking at their post-redesign audit.
Now, before we get too deep into the code, let's quickly define VPAT, or Voluntary Product Accessibility Template. Basically, you can think of it as an accessibility report card. It's the standard document businesses rely on to know exactly how well a piece of software aligns with accessibility standards before they buy it.
So, setting the scene, back in 2024, Slack rolled out a massive UI overhaul, internally called IA4. And whenever you change that much code, things are absolutely going to break. So, post-redesign, they brought in a third-party vendor to do a strict VPAT audit to figure out exactly what wasn't working for users with disabilities. That audit essentially kicked off a massive, comprehensive triage across their entire Android app.
Moving right along to Section 2, fixing the screen reader, or navigating without sight.
Okay, picture this. You type in some invalid input and hit submit. A visual error pops up. But if you're visually impaired and using TalkBack, it's just crickets, completely silent. Obviously, a visually glaring error means literally nothing if the software doesn't tell you about it. To fix this, Slack's engineers tweaked native components, like their text fields and custom banners, to force immediate audio feedback, meaning the second an error happens, TalkBack actually announces it. No more guessing games.
They also tackled the problem of missing structural markers inside lists. If you're looking at a page like Preferences without defined headings, a screen reader user can't scan it or get a feel for the layout at all. By fixing these markers, it basically acts like a table of contents, giving assistive tech the ability to instantly summarize the structure of the page.
Now imagine expecting a list of, say, 5 channels, but your screen reader confidently tells you there are 7. You'd be pretty confused, right?
Well, this specific, kind of bizarre engineering quirk happened because of invisible SlackKit dividers. These were completely decorative, just there for visual spacing, but the Android software was actually counting them as list items. The team swiftly solved this by writing a custom delegate, basically a piece of code acting as a translator to just manually overwrite that item count. It tells the screen reader, hey, ignore the decorations, just count the real stuff.
But here's the thing. Sometimes the absolute best engineering solution is no code at all. Take strike-through text. A user crosses out a word. Sighted users see a line through it, but screen readers typically just read it as normal, unformatted text. So what was the fix? Intentional inaction. Seriously, by consulting directly with the blind community, Slack learned something incredibly valuable. Forcing the reader to announce strike-through begins and strike-through ends actually completely ruins the user experience. It makes the audio impossibly cluttered. It just proves that the general best practice here is simply to avoid using strike-through formats altogether, rather than trying to engineer a way for the software to read them out loud.
Let's shift gears into Section 3, visuals, gestures, and navigation. We're talking designing for cognitive and motor accessibility.
It is honestly amazing how a tiny visual change can have such a massive impact. Look at a search field where the placeholder text disappears as soon as you start typing. For someone with cognitive difficulties, that's a real hurdle. They might look away, look back, and completely forget what that empty box was even for. The fix was brilliant but simple. Just add an explicit, permanent search icon to anchor the field. Boom. Cognitive load dramatically reduced. And here is a fantastic solution to a major motor accessibility barrier. The workspace switcher used to require a manual drag and drop, but if you lack fine manual dexterity, dragging something across the tiny glass screen is incredibly frustrating, or even impossible. So instead of forcing that, they built an accessible edit mode, featuring a visible drag handle and custom context menus specifically for TalkBack.
Just look at how this breaks down the flow. Step 1, you enter edit mode. Step 2, use a simple 3-finger tap or swipe. Step 3, you just select a custom action from a pop-up menu that says Move Before or Move After. It gives the user complete control over their layout, with absolutely zero high-dexterity dragging required.
Also, think about users who literally cannot perceive the color red. If your error messages are just red text, well, to them, it just looks like regular text. Slack realized this, did a system-wide audit, and updated their UI to ensure error states are communicated through varied design elements, like bold icons or structural changes, and not just color alone. Okay, bringing it home with Section 4, Lessons in Inclusive Design, and what engineering teams can actually learn from all this.
When you step back, it's really cool to see how the exact Web Content Accessibility Guidelines, or WCAG standards, map directly to the code Slack fixed. For instance, WCAG Standard 4.1.2, that maps right to fixing those silent error messages and missing labels. Standard 2.5.7 perfectly addresses the dragging movements in the workspace switcher. It really shows how abstract web guidelines translate into real-world app fixes.
So, what are the big takeaways from this explainer? Well, first, you absolutely must announce software errors immediately to screen readers. Second, remember that minor visual tweaks, like permanent icons, massively improve cognitive accessibility. Third, be diligent about adding custom talkback actions for any hidden gestures. Fourth, you gotta collaborate with dedicated accessibility teams and actual disabled users. And finally, recognize that web standards don't always perfectly map to native mobile apps.
That last point is super important, and you can see it captured right here by the engineering team. By taking the time to test against native Google apps, they realize that strict, web-based WCAG standards sometimes actually fail or just feel really unnatural when applied directly to native Android code. You literally have to adapt the standards to fit the platform. I want to leave you with this final thought to ponder, because the journey toward truly native mobile inclusivity is definitely just getting started. Relying purely on web standards just isn't going to cut it anymore. As mobile apps keep evolving at a breakneck pace, how will the industry finally establish native platform-specific accessibility guidelines? It's a massive challenge, for sure, but as we've seen today, the engineering solutions are already out there waiting to be built.